This sample problem is quite long, and I've chosen an acid-base titration on purpose because this is where students tend to trip up. So I want to go through how to calculate the pH along a titration curve in each of the 4 regions that we pointed out. Exactly 1.36 grams of trimethylamine is going to be dissolved in 250 milliliters of water, then 23.60 milliliters of hydrochloric acid was required to reach the equivalence point. Basically, we're asked to calculate the following. Okay, the pH at the beginning of the titration, which is region 1. The pH at the midpoint, or halfway point. Okay, sorry about that. This should read or. And because we're at the halfway point, everybody, this is going to be region 2. The pH at the equivalence point, which is region 3. And finally, the pH after 27.50 milliliters of acid was added. You notice that this 20.7.50, that's greater than the 23.60, which means we are after the equivalence point, and we're out of region 3, and we're into region number 4. All right then, so let's go ahead and do this. When we go ahead and calculate the pH at the beginning of the titration, everybody, remember no titrant has been added yet. So initially, we only have the trimethylamine. This is a weak base. And so let's get the 1.36 grams into molarity right away. So 1.36 grams of the trimethylamine. And we're going to go ahead and divide this by its molar mass, which is approximately 59 grams. And that's going to give us 0.023 moles of the trimethylamine. We're going to go ahead and we're going to divide this 0.023 moles. And we're going to divide it by the total volume at that point, which is 0.250 liters. And we get the initial molarity of the base to be 0.092 molar. Okay, so now it's just a typical equilibrium problem with direct reaction with water. Okay, let's go ahead and write out the equilibrium then. So trimethylamine aqueous plus H2O liquid goes on to form HN1 plus CH3 and hydroxide aqueous. Let's go ahead and plug in all our values. So that's 0.092 molar and 0 and 0 minus x plus x and plus x. This is going to be 0.02 minus x, x, and x. And of course we're going to use KB, everybody, to go ahead and get x. X is then going to give us the concentration of OH minus, and from there we can go ahead and get the pH. And of course we expect a basic pH, everybody, greater than 7 because we only have base present in solution. No titrant has been added in the form of strong acid yet. Okay, so that is part A.